All right, welcome back. We've got a short one for you today. We are covering the case one shortcut, so this makes it a lot easier to deal with these integrals where some we have some numerator, let's call that numerator over a couple of factors like x minus a times x minus b dx, and we can use partial fractions to separate this out into an integral of a constant over x minus a plus another constant over x minus a, x minus b. So that made it a lot easier for us to do these integrals because in most circumstances, integrals like this are just your simple ln integrals, which are going to require a substitution at worst. So today, we want to kind of make it even easier to do these partial fractions. So in the last video, we were looking at a situation where we had three linear factors, and we needed to solve a system of equations to solve for all of the constants that go in the numerator. Now that was hard work. We needed to do a lot of algebra. This is going to require a little bit less, and you'll see why. So let's get started with the case one shortcut. Now this is often called the cover-up method. So the cover-up method goes like this. We're just going to use an example, and it's pretty easy. We only probably need to do one example, and then you'll be good. So I want us to integrate 1 over x squared plus 3x plus 2 dx. Okay, so first, well, we got to factor the denominator, right? So what adds to 3 and multiplies to 2? Well, that's going to be 1 and 2. So we get x plus 1 and x plus 2. So that means that our integral is equal to the integral of 1 over x plus 1 times x plus 2 dx. Okay, well now we need to execute a partial fraction decomposition on this guy, or else we're going to be in a pretty bad way. So we set 1 over x plus 1 times x plus 2 equal to a over x plus 1 plus b over x plus 2. Now we're going to multiply everything by the lowest common denominator, as we would normally. So we get a times x plus 2 plus b times x plus 1 is equal to 1. Okay, now here is where things get important. So what we are going to do is we are going to pick values of x that are strategic for us so that they will zero out one of these factors. Because when we zero out one of these factors, then we're multiplying a or b times 0, meaning that we isolate the other constant, which means we can solve for it. So let's see how this works. So in order to solve for a, so if we want to solve for a, then we want b to go to 0. So if we make this 0, then b is going to go away because it'll be multiplied by 0. So we do negative 1 plus 1 is equal to 0. So we choose x to be negative 1. So let x be negative 1. Thus, 1 stays the same, is equal to a times negative 1 plus 2, which is 1, plus b times negative 1 plus 1, which is 0. So we've got 1 equals a times 1 plus b times 0. Now this b term cancels out, and then we get a times 1 is equal to 1, so that means that a must be equal to 1 as well. So now we've got our first constant. Now to do the same for b, we need to make this factor equal to 0. So we set x equal to negative 2. Then we get 1 is equal to a times negative 2 plus 2, which is 0, plus b times negative 2 plus 1, which is negative 1. So there b equals negative 1. So now we have done our partial fractions decomposition. We're all set. So we've determined that 1 over x plus 1 times x plus 2 is equal to 1 over x plus 1, x plus 1 minus 1 over x plus 2. So now, when we integrate both sides, it's going to be a lot easier for us. So we get the integral of x squared, the integral of 1 over x squared plus 3x plus 2 dx. It's equal to the integral of 1 over x plus 1 minus 1 over x plus 2 dx. Now I would hope that we can all do these integrals because they are very easy. These are just ln integrals, so we get the natural logarithm of the absolute value of x plus 1 minus the natural logarithm of the absolute value of x plus 2. Now that's the cover method. That's how that works. And I'm sure if you had an integration table and you could probably find like a definition if you have just 1 over x minus a, x minus b dx. I'm sure it would give you a solution for how for what that would look like, but that's for another time. So thanks for watching, and we'll see you in the next video, and we'll talk about case 2. And by the way, if you're a BC student, I think you've come far enough in partial fractions